Welcome to episode 6, Lists and Tuples. Last episode we covered strings, which are sequences of characters. Today we cover two more sequence types, lists and tuples. Lists are the workhorse collection type in Python. Tuples are their close cousin. The key difference between them, mutability, is one of the most important concepts in the Python language. A list is an ordered mutable collection, mutable meaning that you can change it after it's been created. We use square brackets and comma separated values. So, for instance, scores equals 88, 92, 75, 100. On that one, 84. That is a list. This is also a list. This one contains all strings. You can mix up the types. So one, Mathy Python, 3.14, here's a Boolean. And it's perfectly fine. A list is just a generic container. You can also have an empty list. This comes up a lot when you start with an empty list and then you build it in some way. Lists can hold any mix of types. Often you'll keep them homogeneous, but not all of the time. Python, as we can see, Python certainly does not enforce that they all be the same type. They can be mixed types. You can also have nested lists. So matrix equals and maybe 1, 2, 3. So this is a list inside of another list. So I'm going to try to format this nicely, but you don't have to. Python doesn't care if you space it out exactly like this. There we go. So I'm essentially creating a matrix here of numbers. And let's print that out, see what it looks like. Okay. So it is a list of lists. That's perfectly legitimate. You can do that. So this kind of matrix is how you would represent a 2D structure. Matrix, a table, a grid. When we get to NumPy, you'll see this quite a bit. Okay, indexing and slicing of lists is similar to strings. So what do I mean by that? So we just created scores. I can index. What is the score at index 0? It's 88. What score is the last in the list? I can also slice, similar to what we did before. So this will give me scores at index positions 1 and 2, not including 3. Do I believe that? So 0, 1 would be 92. At position 2 is 75, not including 3. I can leave the 0 off. Gives me the first 3. I can look from index position 2 onward. So by default, the stop goes through all the way through the last one. And I can I can look at the scores in reverse order. Yeah, 88, 92, 7,500, 84 compared to the original. Our matrix, our 2D list, or our nested lists, list within lists. I can look at matrix sub 0. 1, 2, 3. I can look at matrix. Sub-0 obviously just gives me that 1, 2, 3. And then I can index within that. And what is that? Index position 1 is 2. Here's a key difference from strings. Lists are mutable, so you can change them after creation. So again, let's look at our scores. Let's change the third one, which is at index 2. Let's change that to 95. Okay, so we can see position 0, 1, 2, that's now 95 instead of 75. If you tried that with a string, you would get a type error because strings are immutable by design. Lists are mutable, again, by design, so you can do that. There is an important gotcha, and I don't think this is terribly intuitive if you haven't seen it. So let's take a look at this. 1, 2, 3. Okay, so going back to how variable assignment works, this list 1, 2, 3 is created somewhere in memory. A is a variable that's named A that points to that place in memory that stores 1, 2, 3. If I say B equals A, then this means that B points to the memory location where A is stored. So if I look at what is B, it's also 1, 2, 3. Now here's the tricky part. I'll change the first element of B to 0. I'm sorry, the first element of B to 99. What does B look like? Okay, now it's 99 to 3. Here's the question, what does A look like? Also 99 to 3. Why is that? Well, again, when I created A, I created a list in memory. A points to that place in memory. B points to the same place in memory. So now we have two different aliases, two different names for the same piece of data at the same memory location. So if I change B, that's changing the list at that memory location, which A is also pointing to the same place. So it also changes A. Sometimes you want this if you are, for instance, you have an enormous matrix and you want to look at just a sub piece of it, and you can set a variable to be some smaller piece of it, and then change that, and it changes the entire matrix. So this can be useful. But if you expected A and B to be two different things, then suddenly A has changed, even though you've never explicitly changed that in your code. If you do want A and B to be separate, so let's start over. Let's say A is 1, 2, 3. And now B, not just A, but a copy of A. Okay, A is 1, 2, 3. B is 1, 2, 3. B sub 0 equals negative 999. B, first element has changed. A is still 1, 2, 3. So if you want to be safe and make a copy, make sure you say dot copy. Okay, so there are a lot of operations that you might want to perform on lists, way to manipulate lists. So I can look at the length of scores. It's 5. Let's add an element to it. So I add 91 to the end. Scores. Now it has 6 elements, and the very last one is 91. if I want to insert, not at the end, but some other place, let's say I want to insert a score at the beginning. So at position or index 0, let's put a 70 in there. And now scores. Okay, so the 70 has been added. You can also concatenate lists. So if I have list scores and I want to add, in this case, meaning concatenate two scores to the end of it, I can add these two lists together like this. Notice this is not addition in the mathematical sense. I'm not adding 88 to some score and 70 to some other score. I'm not performing that arithmetic. What the plus means with a list is that you're adding it to the end. So plus is overloaded. That's the terminology. It's overloaded depending on what you want to do with it. It behaves one way with, say, floats. It behaves another way with strings. Behaves another way with lists. I can remove elements. So I can remove the first occurrence of 88. Okay, so the 88 here is now gone. Pop will remove and return the last element. So if you're thinking the deck of cards, it's something like popping off the top card. So that removed the 91. Let's try it again. So here we can see that it popped off that top and it returned it. I can tell it what index I want it to pop from. Doesn't necessarily have to be the end. So now it returned the 70 that was on the front. Take a look at scores. That's what's left. I can delete an element at a particular index. So here we've deleted the 95, which was the element at index position 1. I could sort these in place, ascending. There we go. I could also sort in reverse order. So the option here is reverse equals true. Scores. Okay, so now it's reversed, 192. Scroll up a little here so I can see what I'm doing. So let's say scores, different ways of doing this. I'm going to just concatenate to the end of it. 99, 87, 78, 77. And let's add some more. Let's say 23, 34, 99, 65. So this person's all over the place. Scores equals. I want to replace it. There we go. There's another way to sort scores. So I could use the sorted function. Okay, and that gives me these scores that are sorted in ascending order. If I look at scores, that reverts back to the unordered. So the difference here, scores dot sort will sort in place. It changes scores with that one command. Scores are sorted with scores, returns a list, but it doesn't actually change the list. So what I want to say here is new sorted equals sorted scores. Let's print new sorted, and let's print the original list. Okay, so new sorted is equal to sorted of the scores. Scores, as we see when we printed it, is left untouched. And new sorted is the sorted version of scores. So, point I'm trying to make, if you use scores.sort, then it sorts the scores in place. If I use sorted as a function, it does not sort the scores in place. It just returns a new list. Other useful functions, scroll up. I can sum the scores. I can find the minimum of the scores. I can find the maximum of the scores. I can find the average. There's a function that does this for you in a popular library called NumPy, but we'll get to that later. That gave me the average. There's membership and counting. So is 100 in scores? We saw something similar to this with strings, where I asked if a substring was in the string. Now I'm asking if a value is in the list. It is. Is 55 in scores? It is not. How many times is 99 in the list? Twice. So it's here and there. What is the index of the first instance of 100? It said index 0. What is the first index of 120? That gives an error because 120 is not in the list. Okay, so there's a useful pattern we can use to build a list. And the idea is that you start with an empty list that doesn't yet have anything in it. So I'll call it evens. Then I'll use a for loop. We'll get into the details of for loops later, but we saw before that you can loop. So for n in range of 10, range of 10 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Range gives you that. And I will say if n mod 2 equals 0, so when I divide this number by 2, if the remainder is 0, in other words, is n even, if it is, I will add it to this list I just created. And then we'll print that out to see if it worked. And sure enough. So again, you start off with evens as an empty list. Then I step through the numbers 0 through 9, not including 10. So that's similar to slicing strings, or I suppose lists too, that it does not include the 10. So 0 through 9. N is 0 initially. Is that divided by 2 give you a remainder of 0? It does, so it appends it to the list. 1 is 1 even? No, skips over it. 2 is 2 even? It is, it appends it. Skips 3, appends 4, skips 5, appends 6, skips 7, appends 8, skips 9. Then when I print it, here it is. So the pattern is to start off with an empty list, do some sort of for loop, have some sort of condition of whether you want to include that item or not. If it's true, then you append it to the list. Okay, let's look at tuples. So a tuple is essentially a list with one crucial difference, which is that it's immutable. You cannot change it. So once it's created, it cannot be changed. And the only difference syntactically is that you use parentheses instead of brackets. So here I have a point in space 3, 4. I want it to be a fixed point. I might have an RGB value, red, green, blue. So 125, 128, 0. I don't want that. Okay, 155, 128, 0. I don't want that to change. If I have a singleton, but I want it to not be changed, and I want it as a tuple, I can say 42 and then comma. So a subtle point here, the parentheses designate that it's a tuple, but so does the comma. So if I had 42 without a comma, that would just be a value of 42. That comma is what makes it a tuple. And then let's take a look at those. Point, RGB, and spell. That's something else. EG. Still can't spell. If all else fails, copy paste, right? Okay, that gives me that. The singleton, 42. The indexing and slicing works the same way as it does with lists. So I can say point sub 0. That'll give me the first element, which is 3. RGB, let's go from 1 to the end. So the index 1 is position 2. Okay, 128, 0. If I try to change something, modify the point in place, let's say I want the first element to be 99, and I get an error. Again, because tuples do not support assignment by design. Tuples don't have any append, remove, sort, or any method that would change them. You can look at the length of a tuple, count and index. That's fine. So general rule of thumb, if it is a method that works with lists and it does not change the list, then you can also use it with tuples. So use tuple when the data has a fixed structure that shouldn't change, a coordinate pair, RGB value, a date on your calendar. Use a list when you need to add, remove, or modify elements. Tuples are slightly faster than lists. So if you're looping over something a gajillion times, that might matter. Something else you can do with tuples is unpack them. What do I mean by that? Let's say point is equal to 3, 4. And then I can say xy equals point. Then let's see what x is and see what y is. Okay, so the point is 3, 4. X and y is equal to the point. So it will unpack this. So the 4 gets assigned to y, and the value 3 is represented by the variable with name x. That's how that works. If I say x, y, z equals point, this gives me an error. Not enough values to unpack. Expected 3 got 2. So I said I had 3 variables here, unpack this point and return them, but point doesn't have 3, it only has 2. So that gave you an error. Lists and tuples are both sequences, both indexed the same way, but one is mutable and one is not. So that distinction, of course, it does matter. There are times when you want to change your data structure if you're building it up, for instance. There's sometimes when you don't want to mess with it, it's fixed information that you don't want to accidentally change. So it's better to have an error in the code than to accidentally change it when you didn't mean to. Next episode, we'll talk about more data structures. So we'll talk about dictionaries and sets. Um, Link to the GitHub and the notebook will be in the subscription. If you liked the video, please like and subscribe. See you in the next one. Happy programming.